Alan Lipscomb from Nortec Global HVAC. Appreciate you taking a few minutes of your time today to share with me. I'm going to go over a suggestion that I got from Region 12, so I want to give them a shout out for the suggestion, but we're going to go through setting up airflow and sizing heat strips on AC units with electric heat. The reason we're going to do this is to try to avoid having callbacks. So if it's not set up right, you might have insufficient heat, or intermittently the heat's not working and you end up having to turn around and go back out to a customer's house and try to figure out what's wrong with it after an installation. Because I know a lot of the installations are done during the cooling season. Probably check the heater to see if it comes on, but you might not make sure that it actually functions properly. So the goal here is just to make sure that you're taking a quick look at that, taking some easy measurements, and setting it up properly the first time. As always, I always get all of my information off of nortechhvac.com. At the top of the page is a link to all of our technical literature library. So for the first example, I'm going to review the information that you'll find with the heaters for a straight air conditioner package unit. And it's going to give you information that relates to the heat rise for a particular heater. Now we're going to use this chart, which is only provided with a 10 kW, but we're also going to review with a simple formula how to figure out what your temperature rise would be using other heaters. And our ideal window would be between 30 and 40 degrees heat rise on your heaters. A couple of things to point out. These come set from the factory. There's a little asterisk next to some of the taps. So if it's a single asterisk, that indicates what it's set up for the cooling speed from the factory. And where you have a double asterisk, that's what it's set up for heating speed from the factory. It's not always one size fits all. Sometimes based off of the design conditions or what you're working with, you would have to reference this chart and find out what adjustments might be needed to either the system itself or the duct system to get it within these parameters to operate properly. So the first example that I want to walk through is left-hand side column. We see the different sizes of the package units, and we're going to be working with the O30K. And for the example that we're going to go over here is for a system static of a 0.7. So at the top of the page where I have my external static pressure drop, you see the numbers, they rise as I go from left to right. And let's say for the example here that I've got a contractor that's asking a question about, okay, I've measured my static and it's at a 0.7. Will this system work properly with a 10 kW heater? Well, so we're going to come across that column and we're going to see where our CFM would be for this particular unit at 0.7, and it's the O30K, and it comes with the factory setting for heat on tap number 2, which is going to provide 750 CFM for heating and a 42 degree heat rise. So number 1, that shaded cell tells me that it is not a recommended speed setting. I'm above 40 degrees, and I could run into issues with this system while in heat. It could be opening up the limiter and you're getting insufficient heat. It's not satisfying the thermostat, or it's blowing cold air. So we don't want to go out and install the system in this example here without addressing the speed and heat. So I have a couple of options here. The first option, I can just simply speed that motor up to the speed tap number 3. I'll be delivering 880 CFM, which gives me a heat rise of 36 degrees. I'm within the parameters between the 30 and 40, and I would be good to go. Wouldn't have to worry about it. But I would need to address that, otherwise I might be going back. So this is the formula that we would use if we wanted to look at an option. So let's say that we want to use as an option to see what would be the parameters in the output for an 8 kW heater. So this tells us on the table that based off of the size of the heater, gives us the BTU per hour of the output by the size of the heater. So let's say that we wanted to take a peek at maybe 8 kW to see if this one would satisfy this particular installation a little bit better. So if we look at the 8 kW, which produces 27,297 BTUs per hour. We take that and we use our formula 750 CFM. So that's the setting, factory setting at the static that we looked at, the 0.7 static. So we multiply by the 1.08 and it gives us 810. I divide that 810 into my BTU output, and I'm getting almost 34 degrees. So I should be good to go on that. But it always is going to fall back on what are the specific design temperatures that the customer wants to obtain versus what this unit can actually put out for BTUs. So you always do need to take that into consideration as well. But I'm just giving you this demonstration to show you, number one, you have to always look at that setting for your heat to make sure that you're not getting into the limiter. Number two, you always have options as well based off of your design temperature and design set temperature. We're going to move from here. We're going to talk about split system ACs with electric heat. So just as a reminder, when we send these out from the factory, we don't know the conditions that they're going to go into. So that's why they have multiple speed motors in them. That's why you need to always look at and address each system independently. You should never just plug them in and release the charge and go. You need to know some information about them and set up the airflow for both AC and heat. Now the way ours comes is we have a T connector for both the heat and the cool wire that goes into the motor, and we're setting them up at the low speed. And again, we're trying to avoid callbacks. Common system, 2.5 ton straight AC unit. And if I go to the QRD on this particular system, and we'll have a display of that here in a second, it's going to tell me that I need 895 CFM in air conditioning. But I want to make sure that that 895 CFM in air conditioning is also sufficient for the heating side. Again, for demonstration purposes, we're just going to use the number of a 0.6 for the static reading. And from there, here's my QRD. So the QRD, what I'm searching for here is, what is going to be my CFM requirement for the air conditioning side of the unit? Because if I don't have that set right, I'm going to have performance issues. Well, so I take my, across the top, I have my 030KA. I come down that column and see where it intersects with my B6, BMM 030K-A, and I've highlighted that cell just to show you that, okay, number one, I've got information in that cell which tells me, okay, I've got a good factory match. It doesn't tell me what my SEER rating is, but it does tell me I've got a good factory match. And what I'm going to pull out of that cell is I want to pull out the CFM. So in air conditioning, this unit needs 895 CFM going across that coil for it to work properly. From there, I'm going to take that information of my 895 CFM and I'm going to go to the air handler and I'm going to take a look at the specifications of the air handler and see what will this system provide for CFM out of the box. So again, we were using just as an example a static of 0.6. So out of the box, 0.6 on the low speed tap will deliver 647 CFM. I'm pretty short of my 895 CFM. It's a nominal number, but I don't feel it's close enough to where I'm going to give that customer the capacity and the efficiency that they paid for. Can I get closer to the 895? Yes, if I move that motor tap from low to medium, I'll be delivering 874 CFM. So I'm in really good shape for my CFM in air conditioning at this point in time. So how do I do that? So there is a wiring diagram, lower right-hand corner, you'll see the motor, and you'll have the wires going to the motor. Two of the wires, red and the black, they come together on a T connector that plugs into that blower tap. So all I would need to do is unplug that T connector out of the low speed, move it to the medium speed. Now I have sufficient air for the air conditioning side. So the next important step is, because again, a lot of times you're changing these systems out during the cooling season, so you're just probably making sure that the heat strips come on. You might not be really paying that much attention to them, but we need to take just a few minutes to make sure that what we have installed on the heating side is going to work just as well as it does on the cooling side. So again, we're going to go back and we're going to take a look at our formula, use that with the heater that we're going to install in the system and determine, will this work properly with that heater, or do I need to make another change to the motor speed? So if I go back to my formula, and I look at my 874, and I multiply it by the 1.08, that gives me 914. I divide that into my 27,297. That's the kilowatt output per hour for that 8 kW heater. I'm at right at 30 degrees. So I'm on the borderline of being below an ideal minimum of 30. But can I get there without having to go and change the heater out or do something differently? Well, if I were to slow that motor speed back down on the heating side down to the low tap, which is 647 CFM, multiplying that out, I get 698, divide it back into the BTU hour of the 8 kW heater. Now I have a 39 degree temperature rise. So I am at the higher end of the scale. I'm going to have good supply temperatures coming out for the customer, and I'm not going to have to worry about this particular application. How do I physically do that? So I go back to my motor. I remove that T connector out, and I keep my black wire, which is cool. I keep it plugged into the medium, and I move my red wire to the heat side on the low tap. Well, now I've accomplished, I have one speed setting for cooling, one speed setting for heating. Everything should be within the normal operating parameters, and hopefully that'll be the last you see of that until they're ready for their first maintenance checkup. I hope this was valuable for you. Trying to make these as short and to the point as we can. Always looking for suggestions and feedback. So if you have any, I'd certainly appreciate you leaving it. Hope you guys are all staying safe out there and business is picking up for you. Have a great day. Thanks.